ग्रीटिंग्स ऑफ द डे बेटा। अभी तक आपने सर्कल में बहुत कुछ किया है, सर्कल का फॉर्मेशन, सर्कल का टेंजेंस, और आगे आज हम देखेंगे डायरेक्टर ऑफ अ सर्कल और इंटरसेक्शन ऑफ टू सर्कल्स and then direct common tangents, indirect common tangents. First, direct circle. The direct circle means if you have a circle, if you draw the tangents, two tangents, if the angle between them is 90 degree, that is P A, PB are two tangents. If this angle is 90 degree, then we say that as the locus of the point P. Locus of point P is called director circle. Suppose let us take this one as H comma K and the center is 0, 0. We know the radius is perpendicular and this is perpendicular. So, if you see that as all angles are 90 degree and this equal to this, we know that as the radius, and this also we know tangents from an external points are equal. So, automatically this becomes, that is A CBP is a square. If it is a square, you draw this is 45 degree and this is 45 degree, because the line segment joining the center to the external point bisects the angle between the tangents drawn from the external point P. So, this becomes a 45 degree. Now, we have to find out the locus of this. So, now what is the CP? CP is root of, that is the distance between them. So, it gives us h square plus k square. Then, in triangle ACP, we know that sin 45. It is 45. So, sin 45 equals AC by CP. Yeah, AC equals CP sin 45. AC equal to CP sin 45. So, that is AC, that is R, equals CP sin 45. CP is what? Root of h square plus k square. That is the CP, already we got it. Then sin 45, that is 1 by root 2. So, we get root 2 r equals root of h square plus k square. If you square on both sides, squaring on both sides, we get 2r square equals h square plus k square. So, hk is an arbitrary point of P, therefore, the locus of P is x square plus y square equal to 2r square. It is a director circle with a center origin and we will get the radius as root 2 r. So, this is your director circle, that is equation of director circle. So, the director circle means first of all the tangents drawn from the outside or external point, there between the angle must be 90 degree, then the equation is x square plus y square equal to 2r square. Now, let us move to the next topic, that is intersection of two circles. Intersection of two circles means there are 3-4 cases we will be having. See the first case, it is a circle and another one we have it. Here there is no connection between these two circles. When it is possible, you have C1 as a center, C2 as another circle center. Let us take the R1 as the radius of this big one and R2 as the radius of the second one. Now, how many? Here there is no intersection of these two circles. They lie on the same plane we get. So, in this case, how many common tangents? Common tangents means it is a tangent to both the circle. So, it is a tangent to the both the circle, that is called as common tangents. How many tangents you will be able to draw that? A, B, C, D, E. So, this is one set of tangent. So, if a circle lies on the same side of the line, see this one circle and this circle lies on the same side of this line ABE. So, this tangent is called a direct common tangent. Similarly, CDE, you have that this tangent, this is also a common tangent. For this also these two circles are lying on the same side of a line. So, we say this is also a direct common tangent. So, there are two direct common tangents we will get. Then another possibility also there, if you draw F, G, another H, I, and they intersect at J. Now, you see this H, I, in this one circle is one side, the another circle is another side. So, that type of tangents are called transverse common tangent. So, how many common tangents that is a transverse? One is HJI and FJG. These are the two common tangents, that is transverse common tangents. In this, the circles lies opposite side of the line. So, the number of common tangents to the circles in this case are 4. The one more condition what we will be having, when this is a case, we will get if C1, C2, that is the center, if you join the distance C1, C2, if it is more than R1 plus R2, that is, if the distance between the center, if it is more than the sum of the radii of these two circles, then we get 4 common tangents, that is 2 direct common tangents and 2 transverse common tangents. One more thing, please note it here, that the center and the point of intersection of the two common tangents, that is direct, that lie on the same line. Then this point E divides this line segment joining the center, that is the C1, C2, in the ratio of their radii. That means C1E by C2E equals R1 by R2. That is, the point E dividing this line segment joining C1, C2 externally, that is outside, externally in the ratio R1 is to R2, that is of the radii we get. Similarly, this transverse common tangent also intersecting, that also comes in the same line, that is C1J, C2 is a line. So, this point J divides the line segment joining C1 and C2 in the ratio R1 is to R2 internally, that is point J is inside the line segment C1, C2, so it will be dividing internally, but the direct common tangent that is outside, so that is dividing externally. So, we can say that C1J by C2J equals R1, R2, that means J is dividing C1, C2 in the ratio R1 is to R2 internally. So, we have 4 tangents. What is the condition when we will be getting 4 tangents? If modulus of C1, C2, that is the distance between C1, C2 is greater than R1, R2, we get 4 direct, that is 2 direct common tangents and 2 transverse common tangents, and the point of intersection divides the line segment C1, C2 externally in the ratio R1 is to R2 and internally in the ratio R1 is to R2. In this case too, what we will be having? So, in this case what we will have, that is suppose C1, C2, if it is equal to R1 plus R2, that is the sum of the radii is equal to the distance between the 2 center of the circle, then how many so if it is equal to R1 plus R2, then it will be touching externally. So, this is your R1 and R2. So, R1 plus R2 equal to the distance between the center C1, C2. So, therefore, that 2 circles touch externally. Now, let us see that as how many common tangents will be possible. So, now in this एक set of common tangent है और एक और tangents you will be getting. इसमें क्या है, ये 2 direct common tangent हो गया और ये है transverse common tangents या indirect common tangent भी बोल सकते हैं, that is AB and CD. So, ABE and CDE are 2 direct common tangent, and this you can say that LP is another tangent, that is a transverse common tangent. So, in this case there are 3 tangents or 3 common tangents possible. Three common tangents possible means 2 direct and 1 transverse of a circle. Case 3 में. So, case 3 में क्या है? If C1, C2 is less than R1 plus R2, is less than R1 plus R2 है तो it will intersect. So, this distance C1 plus C2 will be intersecting. In this case, there are 2 common tangents, we get that. So, 2 direct common tangents we get in this case. Now, case 4. If C1, C2 is equals R1 minus R2. If C1, C2 equal to R1 minus R2, then in this case it is C1 and C2. You see that as this one is R1 and this R2. So, the distance between this one becomes R1 minus R2. If this is R1 minus R2, then the circles touch internally. Then we get only one common tangent, that is direct common tangents. Only one direct common tangents possible. All other tangents are imaginary. So, in this case the circles are touching internally, only one direct common tangent possible. Another case 5. Case 5, we have if the distance C1, C2 is less than R1 minus R2. If it is less than R1 minus R2 means it is not going to touch, or simply it will be remaining inside. So, these are the two circles you will be having, that is not concentric, but it will lie inside the circle somewhere. This is C1 and C2. If this is less than R1 minus R2, then we get that as there is no common tangent, because from this you cannot draw any common tangents. So, no common tangents possible. अब equation of direct and transverse common tangent, how we can get that? Already you know that C1, C2, if the distance between the centers is greater than R1 plus R2, then the two circles lies on the same plane, but they never meet or they never intersect or they never touch. So, in that case there are two direct common tangent we get. They meet at a point E, we say if it is AB, CD are the common tangent. These are the two direct common tangents. So, this is your C1 and C2. The line segment joining the centers meet at E. So, these all three lie on the same line, that means they are collinear, and this point E divides this line segment joining the center, that is C1 and C2, in the ratio of R1, R2. R1, R2 we get. Suppose its radius is G1 minus F1 minus G2 minus F2, and its radius we get that as R1 is root of G1 square plus F1 square minus C1, and R2 is root of G2 square plus F2 square minus C2. That means the two circles are of the equation x square plus y square plus 2g1x plus 2f1y plus c1 equal to 0, and x square plus y square plus 2g2x plus 2f2y plus c2 equal to 0. So, these are the two circles, this one its center minus g1 minus f1 and its center minus g2 minus f2, and its radius r1 and r2. We get r1 is this root of g1 square plus f1 square minus c1, and r2 is root of g2 square plus f2 square minus c2. Now, the length we know that this is c1 c and c2, if it is joined, this point dividing this line segment in the ratio of the radius r1 r2 externally. So, we get that C1e by C2e. C1e by C2e is R1 by R2. We know these 2 points and its coordinate can be, we can get by using section formula, because this is dividing this in the ratio R1 is to R2. Let M be the slope of line, or we say common tangent AB. This common tangent is passing through E and the slope is given M. So, we get the equation of a line as y minus beta equals m into x minus alpha. This you get the equation of a tangent AB. Now, we have to get the value of m. How to get the value of m? By, if this is a tangent, means the radius is perpendicular to the tangent. So, we know the distance of this line from the center is radius. Therefore, this one you can remodel it or rewrite it mx minus y minus m alpha plus beta equal to 0. Mx, this y comes that side, so minus y minus m alpha, and this beta goes that side, so plus beta equal to 0. So, this is your equation of a tangent, common tangent. When you know this equation, so this is a tangent equation. So, this one, the perpendicular from this to this line is equal to radius. Therefore, this gives m. Distance of a line from a point is m into minus g1 minus of another point is minus f1 minus m alpha plus beta divided by root of m square plus 1. Root of m square plus 1 we get. This is equal to what? You get the radius. Radius of this circle is R1. R1 is root of G1 square plus F1 square minus C1 we get. So, this is, that is a line, it is a tangent. If it is a tangent, means the distance of this line from the center is equal to radius. So, we get this portion, that means minus mg1 plus f1 minus m alpha plus beta equals root of g1 square plus f1 square minus c1 into m square plus 1. This is also into root. So, it is a positive value. So, we can keep it as this one. So, we get this as a quadratic in m. So, we get the values of m from this and put it in the equation here. We get the required equation of a tangent, that is AB equation you will get. So, this from this we know G1, we know F1 from the equation of a circle, and then we know the point alpha and beta from this by solving this by external division. So, we substitute and we know the radius, from there we get a quadratic in m. So, that value of m if you get and replace it here, you will get the required equation of the direct common tangent. Similarly, you have here these are the two transverse common tangent. These are the two transverse common tangent. In this common tangent, so suppose if you have that as this is a f, this f is dividing this line segment C1, C2 in the ratio of radius. In the ratio of radius means you get r1 by r2. So, from there what we can get? We can get the coordinate of f. Similar way, let m be the slope of a line and the coordinate, if you take this one as alpha 1, beta 1 as the coordinate, then we can get the equation as y minus beta 1 equals m into x minus alpha 1. Again this is a tangent. So, this is a tangent mean from the center its distance is equal to radius. From there we get the coordinate of m, or we get a quadratic in m. So, from there the value of m you get it, and then equation of the tangent, that is transverse common tangent we can get.